there's no slowdowns in this case, because we just get the correct depth and velocity, and vision obviously has the vertical resolution to differentiate a bridge from a car and whether or not the car is floating in it. So again, you could go into the vision stack, the radar stack, or the sensor fusion stack, and if you have an improved depth and velocity, you could change the fusion strategy. But again, you're just kind of like doing dead work. Like, this signal is so good by itself. Why would you do that? So in this setting now, we've improved the situation quite a lot. Here's another last example. We have a stationary approach. Again, this is in track testing environment. This is an example of a test that we would run. And we are just approaching this vehicle and hoping to stop. What you see in orange in the legacy stack is that it actually takes us quite a bit of time for us to start slowing. And basically what's happening here is that the radar is very trigger happy, and it sees all these false stationary objects everywhere. Like, everything that like sticks out is a stationary target. And radar by itself doesn't know what actually is a stationary car and what isn't. So it's waiting for vision to associate with it. And vision, if it's not held up to a high enough bar, is noisy and contributes sort of error. And the sensor fusion stack just kind of like picks it up too late. And so again, you could fix all that, even though it's a very gross system with a lot of if statements and so on, because the sensor fusion is complicated because the error modes for vision and radar are quite different. But here, when we just work with vision alone and we take out the radar, vision recognizes this object very early, gives the correct depth and velocity, and there's no issues. So we actually get an initial slowdown much earlier, and we've really like simplified the stack a lot, and as well. So just speaking very briefly to the release and validation, we've extensively validated this before we, of course, ship this to customers. Just some example numbers for the validation itself. We've handpicked about 6,000 clips in about 70 categories of scenarios, like harsh braking, crossing vehicles, different vehicle types, environments, and so on. And we run these tests on all the commits of the build, and we run them also every day periodically as we were trying to drive up the performance on these clips. We also use simulation extensively for validation. We've also used simulation for training, although I haven't gone into that, but we've had some successes there. But we use it primarily for validation at this stage, and that's again like diversity of scenarios, trying to make sure that the stack is performing correctly. We've done a lot of track testing, and I've shown you some examples of that. We've driven this extensively in the QA fleet, and we've also deployed this in shadow modes and seen that this stack performs fairly well. So in particular, for example, for the automatic emergency braking, we actually see a higher precision and recall compared to the legacy stack that is a fusion stack. And so having seen all this, we've actually released this. We've accumulated about 15 million miles so far, and 1.7 million of those have been on autopilot, and so far there have been no crashes. Now, of course, we're running at massive scale here, and so we do expect some crashes at some point. The legacy stack has a crash roughly every 5 million miles or so, I believe, and so we do expect some incidents at some point. But the improvements for the vision stack are not sort of stopping, so I think we're very confident that we're barking up the right tree here, and that we can actually get this to work really incredibly well. I also wanted to briefly give a shout out to autolabeling as an incredibly powerful method for sourcing training data. So we're applying autolabeling to all of the FSD tasks, not just the depth and velocity of the car in front of us. Here's an autolabeler for pedestrians, and you can see that the tracks are very smooth. And this is, again, a completely offline process that we are applying not just to objects, but also to a lot of static environments. So this is some example of a 3D reconstruction. So here we see a clip, and this is a vision-only estimate of the depths of all the points. And of course, you don't actually want to really deploy these measurements directly into a car because they are too raw. So what you actually want to do is you want to, again, auto-label, and you want to really think about what is the information I really need at test time in the car, and what is like as close as possible to action, right? So you want to do all this work at training time, figure out exactly what happened in the clip, reconstruct the entire environment, and then you want to actually like post-process the curve at training time. So you want to do as much at training time and labeling time as possible, and then you want to figure out what are the tasks I really need at test time, and that's the thing that happens in the car. Subject to very strict latency requirements. You want to do as little post-processing there as possible. So we see that this is a very powerful lever on creating data sets. So in summary, what I try to argue and give you a sense of is vision alone is actually our finding that is perfectly capable of depth sensing. It is an incredibly rich sensor in terms of bandwidth of information, and doing this and matching radar performance and depth and velocity is incredibly hard. I believe it requires the fleet because the data set that we were able to achieve was critical in all these performance improvements. And if you do not have the fleet, I'm not 100% sure how you can source all the difficult and diverse scenarios that we did source, because I believe that was critical to getting this to work. So it's hard, it requires massive networks, a supercomputer, and a data engine, and the fleet. But all of these components are coming together in a vertically integrated fashion at Tesla AI. And I believe that this makes us sort of uniquely positioned in the industry, where we are barking up the right tree, and we have all the puzzle pieces to make this work. And so if you are excited about this approach that we're taking and the networks and the work that we're doing, then I would encourage you to please apply and join the team and help us make this a reality. So you can go to tesla.com/autopilotai